Hi everyone, welcome to my YouTube channel, and in this video we will look at problem 622 from Leetcode. So this problem is very popular and I don't think this problem is too difficult. Having said that, even if you are stumbled on this problem and you cannot solve this problem in 30 minutes, do not get discouraged. I really want to emphasize that you do not want to get discouraged over not solving this Leetcode problem in 30 minutes. You just have to remember a few things like to solve this problem. It's just a few minor tricks, but after that I don't think you have to worry about this kind of problem. If you are, and I think hopefully after watching my video you will be able to solve this problem without memorizing this stuff. Okay, so let's look at how we solve this problem. I would say the first thing we have to do is we do have to come up with some few variables, and obviously the circular queue will be the queue that we will be building, and then that's the circular queue. And we have insert index, delete index. So insert index will be the index position that we will insert new element at insert index +1. Okay, and then delete index will be the index position where we will delete. And then the count variable is how many elements we have inserted or not. So whenever we inqueue some number, we will be incrementing our count variable by 1, and whenever we dequeue a number, then we will decrement our count variable by 1. So that's going to help us to implement isFull method and isEmpty method. So let's look at Inqueue first. So we have an Inqueue method, and so here we do have to consider two cases. Initially we set insert index and delete index equal to -1, and then we have two cases. Okay, and then so one thing that I want to mention is this trick. So this is a circular queue, meaning that if we are at here and the next element will be this guy, right? And so how do we move from here to here? Typically the way you do that is you use this modulo function here. So we have insert index +1, and we take the modulo of the length of this circular queue. Our length here will be 8, and say if we are at here 7, the next one will be 7 + 1, that is 8. 8 modulo 8 will be 0. So that means we are at here. Suppose we are at here, so insert index is equal to 1. The next index will be 2, but using this one we see that 1, our insert index is 1, so 1 + 1 is 2. 2 modulo 8 is 2, so that's gonna be here. So that's one trick that I want to mention. So we have two cases. If circular queue of next insert is not equal to -1, then I want to mention this one. So when we initialize our circular queue, since the value is going to be from 0 to 1000, I think, so we can initialize all this circular queue and then initialize this this value by -1, because we don't have -1 in our value constraint here. So here we have a 0 to 1000 inclusive, so we can initialize them to be -1. And if our circular queue at next insert is not equal to -1, that means we already have filled that position. So in that case it will be something like here. So that's gonna be the first case. Our insert index is 53, and then we want to insert the insert index is 7, and we want to insert, say, I don't know, number like 100. To then we do have to look at this next insert, and we notice that this is not equal to -1. That means this one is already filled with this number 1, so we cannot insert this 100. So in that case we return false. Otherwise, so in this case, this is another case. We have an insert index equal to 6, and then the next element is -1. What that means is we have not invoked dequeue method so far. So so this example we haven't used dequeue method. Otherwise we would have -1. So same here. Now we notice that insert index is 6, and then the next insert is 7, and we notice that this is -1. That means we have not yet inserted any number. That means we can set this value to be whatever value we have in our parameter, and then we change insert index to be next insert, and we also have to increment our count variable by 1. Dequeue method is similar. We define a local variable like next delete. So next delete is going to be delete index plus 1 modulo length of circular queue. And so again, two cases to consider. If count is equal to 0, like in this case, all elements are equal to -1, that means we have not yet invoked Inqueue method, so count is 0. If count is 0, then we cannot dequeue this circular queue. We cannot, if count is equal to 0, that means we cannot invoke dequeue method because we haven't inserted any number, right? So or you can also check if circular queue of next delete is equal to -1. In this case, next delete is 0 and this is -1. So either you can do two things. If count is equal to 0 or if this is equal to -1, then we return false. Okay, so this either one of them works. Otherwise, we have this case. So if you look at this case, what's going on here? We have invoked Inqueue method 4 times, and then we invoke dequeue method 2 times. That's why we have -1 here, like in front of this 3. And in this case, our delete index is pointing here, and then the next delete is 3. Next delete is 2. Circular queue at next delete will be 3. And if this is not equal to -1, then we decrement our count variable by 1, set both delete index equal to next delete, and then we set this guy to be -1. Instead of 3, we set that equal to -1. Other remaining 4 methods, they are very simple. We will be using, so first we have a front that's going to be, so if you look at here, which one is so if you invoke front method in this case, we will have to return 3, right? And then this one is going to be delete index plus 1 modulo length of circular queue. So we just return this guy. And because delete index will be the index position that we just dequeue, so the next element will be still, not equal to -1. So and the real method will be the last element, and then we will be using insert index in this case. So we simply return circular queue at insert index. And then for empty and full, for empty, if count variable is equal to 0, that means we have empty circular queue, so we return true. Otherwise, we return false. And for full, we are given this k value. K is the value k, so k will be the size of this queue, and then we will be comparing that to our count variable. If they are equal to each other, then that means our circular queue is currently full, so we return true. Otherwise, we return false. So that is that, and let's look at the code for this problem. So here is the code for this problem, and we have, so this is our init method, and we have initialized 5 variables here, and we have an Inqueue, dequeue, front, where is empty, is full. And this part here, you can also use, if self.count is equal to 0, or you can also use if self.circular queue at next delete is equal to -1. You can use either one of them, and this will still give you the right answer. So let's try run this together and see what we get. Okay, so that's for this part, and let me try uncomment this section and comment this section and see what we get. Yes, so the same thing. Yeah, so that's for this video, and I will talk about other topics. I still haven't forgotten about the numerical linear algebra, and I'm thinking about doing some more problems in this field, in this area, and what else? I also have to talk about the calendar problem. Yeah, so I've been busy over the past few days, so that's why I was not able to upload videos as usual. Yeah, so that's for that. So thank you so much, you guys, for watching my video. And if my video helps you guys understanding this problem, please give me thumbs up and subscribe to my channel. And I'll see you guys next time. Bye bye.